Welcome to a beginner's guide to photographing the moon. This was only going to be a very brief introduction and will just give you a taste of what we can do with some basic equipment and some more advanced equipment should you wish to proceed on to the next stage. Okay, so will be going through what we need to use and how to use it, what you will be able to see with your equipment on the moon, the phases of the moon and how the terminator reveals the lunar landscape. And then we can capture the moon in the daytime, some moonscapes, and capturing other different features that we have on the surface of the moon. Okay, so first of all, we need a telescope, a camera, maybe a digital SLR, or if you go to the more advanced route, an astronomical camera. So here we go with a telescope. This is only a smallish telescope, a 71mm objective lens with a focal length of about 420mm. It's a bit like a long telephoto lens that photographers would use to get close-ups of wildlife, birds, etc., sports. So something similar to that. But this one has only got three glass lenses in there to deal with the photographs. Unless you have a very long telephoto lens for your camera, most people will have maybe a 70 to 200. So if you do have something around that sort of focal length, then just use a teleconverter of 1.4 times 2 will help. But bear in mind you will either use one stop or two stops of light using those teleconverters. If you're going down the more advanced or professional route, then you will need a dedicated astro camera, which is basically the sensor that you get exactly the same as in a digital SLR, and either a fan at the back, which will either make it cooler to keep the sensor from overheating, and then you can get it in either a mono, black and white, or a color sensor. More advanced users will prefer the mono sensor so they can use color filters to get a better reproduction and sharper images with the mono sensor rather than having a dedicated color camera. The color cameras are cheaper and it's a quick fix to get your images if you're rather impatient, but we all have to start somewhere. So, when you have a look at the moon through a pair of binoculars or even through the telescope, you will see dark and light areas. The darker areas are either called mare or seas, or oceanus, oceans. These are all from the Latin names. And the lighter areas are due to the fact that lava has flown across the areas there, covering up all the impact sites from the craters that were previously on the surface. And you may notice as the moon gets fuller, you will notice some bright rays coming from several of the areas on the moon with craters, and as you can see, those were the impacts from the asteroids or whatever was hitting the surface of the moon, and the debris flung far and wide away from the impact site. And obviously, because there is no atmosphere and a lower gravity effect on the moon, that impact will have a greater and far-reaching views of the rocks strewn across. And here is just a few of the names of the seas and some of the craters. There are thousands and thousands that are already there. So, why do we get the phases of the moon? Well, obviously the moon will rotate around the Earth And because it rotates roughly at the same time as it orbits, we will get the same phase of the moon all the time. So it's like a tidally locked view of the moon. And therefore we can just see only roughly 50% of the facing moon. Now, as the moon's phases grow from new to full, and then from full back to new, we will get details of the shadows of the craters, which will be enhanced when the angle of the sun is where it's quite low to where the craters are. And that gives us the best opportunity to get the best details of those craters and what is contained in them. So as you can see from here, the phases of the moon gets gradually more and more as we work our way through to the full moon stage, and thus revealing a lot more details as we get further across. But unfortunately, as it gets towards full moon, the lighting on the moon becomes almost overhead, and then we don't really get much detail at all. So having a full moon is not really the best way to photograph it, apart from the fact that it's very bright. But if you want to do it during the daytime, why not? Just because you see it at night time doesn't mean it's not there in the daytime. And you can just take some nice opportunities to photograph it in its phases in the blue sky and clouds, which can make quite an interesting picture. You can still take photographs of the moon with some details if you know how to process the pictures, and they can become quite very interesting to look at. Obviously, the best contrast is when you do get to have it at the night time. But then we can put moonscapes, where we can generate a picture of the moon by using a telephoto lens from a distance with a various landmarks in the distance, and it gives you some aspect of what size the moon is when it gets quite close to the horizon. And most people seem to think that the moon is bigger when it's got something to be compared with. These images here are from the local area. The one on the centre and the one on the right is the Glastonbury Tor. And if you get the phase just right using an app, you can get it coming up just behind the Tor, which is looking quite impressive. Okay, so when the moon is traversing through the sky, sometimes it occults or covers over an object. And this object here we've got is the planet Saturn. And as you can see, it's gradually getting obscured by the surface of the moon. And it gives you an idea of how the sizes of the planets are in relation to the surface of the moon. And here we have a daylight encounter of Venus. As you can see, Venus is just over the first half phase there of the because it is on the inner orbit to the Earth, so it obviously shows phases like we have for the moon, and it just gives you an interesting comparison of the sizes here. But Venus is obviously being closer and a larger size relative to what we just seen with Saturn. It does look quite bright and a decent size. Okay, so we are now going to have a look at some of the different features on the moon that we would like to see. And as you can see, we've got valleys and we've also got mountains on the moon here. So we can get similar features, but obviously these features are a lot bigger than what we normally get on the Earth. Okay. And then we've got some valleys down through here as well. Collapsed lava tubes and the like that we can also get features of. And because there's no wind erosion, they do seem to stay quite well. Now this one, which we've got in the crater Petavius, is apparently a collapsed lava tube. So that would be quite an interesting place to go and see how large and deep that will be. And if you're really interested in doing things from the Apollo landing sites, we've got one here of the Apollo 15, which was near Hadley Rill. And I've managed to get the Hadley Rill into view. Well, you obviously need to be able to get the right phase of the lighting to highlight the rill through the mountains there as well. And I've just about managed to get the area of the Apollo 15 landing site. And here we have just a little montage of some of the moons here, drawing its various phases. The one on the bottom right is the start of a lunar eclipse. But as usual with the British weather, it decided to get cloudy, and I just couldn't get any more luck with the further improvements to get the totality of the lunar eclipse. But I will get there one day. And that's all I'm going to say for this presentation. Thank you for hopefully you've managed to get some information from this little brief tutorial. Thank you very much.